Hi, welcome to my channel, Math Made Easy with Laurel. I'm Laurel, and in this video we're going to talk about the standard normal distribution. In the previous video, we talked about what a normal distribution was, and we looked at the properties of a normal distribution. We know it's the most common type of distribution, and the two most important factors in describing a normal distribution are the mean and the standard deviation. IQ scores are normally distributed, and we know the mean is 100 and the standard deviation is 15. Mean is in the center, so we know the mean is 100, and standard deviation is 15. So if we go 15 units on either side, that's one standard deviation on each side. Go another 15, that's two standard deviation, and so on. Using the empirical rule, we were able to find the area under the curve between IQ scores of 115 and 130, which represented the portion of the population that had IQ scores between 115 and 130. It also represented the probability that a randomly selected individual has an IQ between 115 and 130. However, the empirical rule is really very limiting. We can only find the area under the curve for certain values. We want to know how to find the area when our IQ score is any value. So for example, if I wanted to know what percentage of the population has an IQ score over 110, my empirical rule is not going to help me. So what we're going to do is standardize our normal curve and then talk about how we can find area under the curve for any value. Let's take a look. So a standard normal distribution will have a mean of 0 and a standard deviation of 1. So when we go to the right, that will be positive, and when we go to the left, that will be negative. Two standard deviations from 0 will be 2 to the right, and two standard deviations from the mean to the left would be -2, and so on. Mathematicians have used integral calculus to find the area under a standard normal curve for any values along this horizontal axis. The values along the horizontal axis are referred to as Z values or Z scores, and the tables will tell you the areas for a wide range of Z scores. Let's take a look at some examples so I can explain with examples how we use the tables and how we determine the areas. You will probably see the questions written like this, and this means what's the probability that Z will be less than 1.35. And anytime you see Z, they're talking about a standard normal. So let's make a drawing of what that might look like. Remember, it's our standard normal curve, so our mean is 0. 1.35, it's positive, so it's going to be over here somewhere. And they want to know less than, so we're interested in finding the area to the left of that Z score 1.35. I like to make a drawing to see the area that I'm looking for to get an idea of how large or how small it is. Now let's go to the table. This is the table that we're going to use with a Z score of 1.35. If you notice on the left, the Z scores run from 0.0 to 3.4. They're all positive. And if you look at the diagram, the shaded area shows you that we're finding the area to the left of the Z score. So for 1.35, we're going to go down our left-hand column and find 1.3 and go across. Then at the top, we're going to pick 0.05 so that we get 1.35. The intersection of those two lines will be the area that we're looking for, 0.9115. That's the area to the left of the Z score, 1.35. From the table, we found that the area was 0.9115, which is the same as the probability. We can leave it in decimal form, or we can write it as a percent. My second example, I want to find the probability that Z is greater than or equal to -2.3. I want to point out that you might see the equal sign with the inequality sign, or you might not, and you do it exactly the same. That will not make a difference. So if it was just greater than -2.3, the answer would be the same as if it's greater than and equal to. So again, let's make a little drawing. Our z-score is negative 2.3. So that will be to the left of the mean. And we want the area to the right because this is greater than this value. So we're looking for this area right here. Our table only gives us the area to the left. So what you need to understand is that the area to the right will be 1, subtract the area to the left. This is the area to the left, less than negative 2.3. That's what the table will give us. We know the total area is 1, so 1 minus this will give us the area that we want.
This is the table that we're going to use for negative z-scores. You'll notice along the column on the left-hand side, those are all negative z-scores. And we're looking for negative 2.3. So find negative 2.3 and highlight that. The digit in our 100th decimal point is a 0. We're looking at 2.30. So let's take that column. The intersection of those two lines is the area that I'm looking for, 0.0107.
We obtain 0.0107. We subtract that from 1. Therefore, our area under the curve to the right of this z-score is 0.9893. And as a percent, that would be 98.93%. In our third example, we'd like to find the probability that z is between 0 and positive 0.98. What will that look like? 0 and positive 0.98. So we're finding this area here. In order to find that, we're going to find the area to the left of this z-score and subtract the area to the left of this z-score. So we'll start off with the area using 0.98 as our z value.
We're working with a positive z-score, so this is the table that we're going to use, and we are looking for 0.98. So we look for 0.9 on the left, and then 0.08 at the top. The intersection of those two lines will give us the area we're looking for, 0.8365.
That value is 0.8365. We're going to subtract this area. This is right in the center, so we know that that area is going to be 0.5. And if you look it up on your table, you'll also find it's 0.5. Let's subtract. Our area is 0.3365, so is our probability. And as a percent, it would be 33.65%. One thing I'd like to point out, because I saw students make this error, students got mixed up between what a z-score was and what an area was. There's our z-score, that's the value on our horizontal axis. This is our area, which is area under the curve. So know the difference between a z-score and area. Keep that straight at all times. Last example, what's the probability that z will be between these two scores? I'm going to find the area between those two z-scores. Quick drawing. Mean is 0. Negative 1.23. Don't have to be too exact here. Positive 2.06. And we're going to shade the area we want to find. Again, we're going to start with the larger z-score, find the area to the left using our table, and then find the area to the left of this z-score and subtract.
Let's find the area under the normal curve with a z-score of 2.06. Let's find 2.0 first, then 0.06 column. The intersection is our area.
The area corresponding to the z-score 2.06 is 0.9803. Let's subtract the area corresponding to this z-score.
Let's find the z-score, negative 1.23. Notice that we're using the table that has the negative z-scores on it. First of all, find negative 1.2. Then find the column for 0.03. The intersection of those two lines will be the area that we need.
This area is 0.1093, so now let's subtract. Our area is 0.8710, therefore that's our probability, And as a percent, it's 87.1%. I just want to mention that you hopefully won't see a question like this, a z-score equaling a specific value. And if you do, that probability is just 0. If it's equal to a certain value, there's no width, there's no range, so you can't get an area. There's not 2 dimensions. So hopefully you won't see that, but if you do, understand that that probability would be 0. It's a good idea to practice using these tables to find a variety of areas, either to the right or to the left or between values. But how does this relate to regular normal distributions like IQ scores? How can we use this to find area under those curves? Well, we do it with a simple formula where we change those values to z-scores, and then we can use our tables. And I'm going to cover that in the next video, so I'll see you then.